Hi, everyone, and welcome to Echo Live, the Michigan Science Center's weekly program brought to you live on Facebook, YouTube, and right here in Zoom. If you haven't done so already, you can go ahead and introduce yourself in the chat from wherever it is you are watching live from. Today, we have a really exciting program planned. We are going to talk about the history of the light bulb. I want to talk about a little bit of fact and a little bit of fiction that comes with one of science's most notable inventions. Now, if you know a famous scientist or inventor who maybe has something to do with the light bulb, you can also let me know who you think that might be in the chat. But our goal is to talk about a few of the different scientists who contributed to the light bulbs that we've used in the past, as well as the ones that we use today. So let's get started way at the very beginning. Now, people often credit one specific scientist with inventing the light bulb, and you might know who that is. If you have guessed, you can put that one in the chat. But actually, the very first mention of something like an electric light bulb goes back even earlier than that very notable scientist that we'll talk about in just a little bit. Way back in 1803, in England, scientists first began work on creating an electric light bulb, which was the goal was to power up our homes in our cities or to light up our homes in our cities without using something like an open flame. Now, using fire or flames as a light source does work, but it does come with all sorts of disadvantages. Number one, it can be very, very dangerous. Number two, it's not very efficient. And number three, sometimes fuels for those flames can be incredibly hard to come by. So scientists and inventors back in the early 1800s, 1803 is the first time that scientists patented an electric bulb. They called this the arc lamp. And on the screen, you can see some of those very early designs or patents that were issued in England for the very first arc lamp. Now, the premise behind an arc lamp was very simple. Scientists were trying to find a way to sustain light by heating up some sort of metal using electricity. The premise behind this is very simple. And we can actually recreate that using some similar materials that I have right here inside the studio. Now, you might remember this one. We do this one during some of our fire programs, but I have a small piece of metal, very, very small, silvery looking piece of metal, but in fact, this is not silver. This is a tiny strip of a metal that we call magnesium. Now, magnesium is a mineral that we find in food, but in its metal form, in its solid metal form like this, it actually makes a great fuel for a fire. Now, what's unique about magnesium is that this also produces a quite bright light when it starts to burn. So for this, we are going to need a couple of our handy dandy supplies here that I have in the studio. I've got a Bunsen burner, which is going to supply us with the heat for this reaction. Go ahead and light our Bunsen burner here. And now I'm going to put on a safety glove since we said that using flames or heat in order to produce light can be pretty dangerous. I'm just going to slowly start to heat up our piece of magnesium here, just placing it directly in the flame, causing it to get nice and hot. Now, those first arc lamps that we saw in that patent actually worked using a very similar process. Sending electricity through a really small piece of metal, really very similar to this piece of metal that I have here on screen, causes it to glow really, really brightly. So as soon as this piece of magnesium gets bright enough, we should see it start to emit a very, very bright white light. Look at that. Magnesium burns incredibly bright, but we can see that relatively quickly. I no longer have a nice big piece of magnesium metal. It's reduced almost entirely to ash. But these scientists, they didn't give up. We continued innovating to bring us different iterations of the light bulb, using different sorts of metals as filaments and using different types of materials so that our lights would last much longer. The next step in kind of the evolution of our light bulb, we have a scientist who actually created the first sustained or constant electric light. This is also over in England, which is part of the reason that, at least here in the US, when we learn about the history of the light bulb, often our history starts with Thomas Edison. But you'll notice that Thomas Edison hasn't come up in our timeline yet. And that's because scientists in other countries around the world were working on things at the same time as him or even earlier than him. So this scientist here was credited with sustaining the first constant electric light. But still we had issues with filament, how long it could last. And at the same time, scientists were actually working on a totally different idea. Scientists thought, well, those filaments aren't working so great. Even though we're able to sustain constant light, there's all sorts of issues. The metal degrades over time, it takes a lot of energy, and it produces a lot of heat. And so at the same time, scientists invented something called, oh, my slide will switch here. We are not at Thomas Edison yet. I'm gonna go ahead and switch my PowerPoint here. Oh man. All right, we invented something called the Geisler tube. And a Geisler tube is a device that we filled with various gases or elements that we find on our periodic table, and we electrify those gases with electricity. I have what we call now a spectrum tube, but this is derived from those very first types that we called the Geisler tubes. And inside each of my various light bulbs, I've removed all of the air except for one specific type of gas. Now, this demonstration will work best if I go ahead and turn off my virtual background and then turn off the lights here inside my studio. In just a moment, I'm going to turn on the electricity to my spectrum or Geisler tube, and we'll get to see what color this element glows when it's electrified with electricity. Take a look. This element is element number 1, which you might know from the periodic table as hydrogen. Hydrogen is the most abundant element in our solar system because most of the sun, that big fiery ball that we see up in the sky, is composed of hydrogen as well. Now, Geisler tubes were the first ancestor of what we now know as a fluorescent light bulb. And these were actually invented well before Thomas Edison even ever received his first patent for a light bulb. So these still came before Thomas Edison's time. These actually came back in the year 1850 is when Geisler tubes were first introduced. And here is kind of a design or a mock-up that scientists drew up for their patent for those Geisler tubes. Now we can put all sorts of different gases, right? The next one we'll put in is element number 2. So if you happen to know what element number 2 is on our periodic table, you can type that in the chat. Now, if these look familiar, they probably look familiar because we use something similar to a Geisler tube or a spectrum tube in neon signs. Neon is actually one of those elements on our periodic table. However, neon is not element number 2. Element number 2, if you guessed it or you know it, it is helium. That same gas that allows balloons at a party to float up in the air is the same gas that's inside the tube we see on screen right now. And this one glows a different color than hydrogen. It has to do with the number of electrons that this atom or element has, causes it to glow different wavelengths of light when they are electrified with electricity. Let's take a look at a couple more. So we've seen hydrogen, we've seen helium. Let's take a look next at mercury. Now we see liquid mercury pretty commonly here. If you've ever seen a thermometer, that red liquid inside is liquid mercury. So maybe you know or think you know what color this gas might glow. But wait a minute, liquid mercury is red. If liquid mercury is red, why isn't our spectrum tube glowing red? Well, like we said, when we ionize this gas with electricity, different frequencies of energy or light are emitted. And so mercury actually glows this very, very beautiful, bright blue color. So if you've seen a blue neon sign on something like a business, it's highly likely that there is mercury gas inside there. Let's take a look at one more, the one that gave neon signs their name. Last one we'll take a look at is neon. So that's very last spectrum tube, derivative of those Geisler tubes invented in 1850. This one is neon. And neon is really, really bright and noticeable. Neon glows red when our Geisler or spectrum tube is full of just neon gas. Remember that all other gases have been removed from these tubes. It's like a vacuum inside, and we only fill it with the one gas that we want to be electrified by this light. Now, after 1850, scientists really, though, wanted to figure out how we could use different types of light bulbs and get them into people's homes and into people's cities. So we really had to go back to those incandescent bulbs. Now, by 1880, this was the time that Thomas Edison enters the light bulb scene. So here on the screen, we see Thomas Edison's first ever patent for an electric light bulb. So this was his very first patent. He actually had quite a few over the years, but the very first one utilized that filament inside in order to create light, just like the others that we've seen so far. But the issue was that this light bulb filament was breaking down just like all the others. Since you have to use a really small piece of metal, really, really thin, it was really difficult to find something that lasted long enough that you could actually sell it to people and use it for longer than maybe a couple days. It was a challenge that scientists had to come together on. So next, the last scientist I want to bring up today is this guy, Lewis Howard Latimer. Lewis Howard Latimer has an amazing backstory. He's definitely someone you should look into his history online. He's actually credited with lots of inventions, so he was an inventor himself. But his contribution to the light bulb actually has to do with writing a patent. So the patent you see up here on the screen is actually Lewis Howard Latimer invented and helped to patent the process that helped to stabilize those filaments inside the light bulb. All the issues we've brought up so far with making filaments last a really long time was solved by Lewis Howard Latimer's invention, the one that he received the patent for in 1882. Just 3 years after the first Edison patent came out. So here on the table, I have an example of something actually quite similar that you could create at home that utilizes a similar material to what Lewis Howard Latimer wrote his patent for way back over 100 years ago. So down here on the table, I have a few very simple supplies. I've got some wires, which are going to allow me to provide electricity to my makeshift light bulb here. But instead of plugging this light bulb into the wall, I actually just taped together a stack of D-cell batteries. So this is going to provide enough voltage to electrify the filament that I've created using something I'm sure you all probably already have at home, which is just a piece of mechanical pencil lead. So if I zoom in my camera here, you can see that I very carefully put one piece of mechanical pencil lead between my two wires or electrodes here. Now, this carbon filament, or graphite, which is a type of carbon, is actually made out of the exact same material that Lewis Howard Latimer's filament is made out of. However, this hasn't gone through that process that he patented. So this filament is incredibly unstable. It's not strong. And so we'll see what happens as we send electricity through this filament here, this pencil lead filament. We'll zoom out just a little bit so we can get a good view of me setting up the rest of our light bulb here. All we need to do is send the electricity through our filament, causing it to glow, and we should see our own makeshift light bulb in 3, 2, 1. You can see smoke, right? I see smoke, I see bright light. Our light bulb is working, it's working, it's working. But since we said that this filament has not been stabilized by the process that Lewis Howard Latimer patented in 1882, this filament is not going to last long. Definitely so far lasting longer than our piece of magnesium, so perhaps carbon is a better material for light bulb filaments than magnesium is. But if we take a really close zoomed in look, we can see that our filament has still heavily degraded over time. Now, this is the last scientist that we're going to talk about today, but of course the evolution of light bulbs did not stop in 1882. Now we don't see incandescent or Edison light bulbs as often. That's because it's not a perfect process. Actually, about 80% of the electricity that we send into filament or Edison bulbs goes to waste because it's released into the environment in the form of heat. Now we more often see fluorescent light bulbs. Thomas Edison did a lot of work with fluorescent light bulbs, which are again a derivative of these Geisler tubes that were invented way long before Thomas Edison ever received his first patent. But these fluorescent light bulbs are becoming more and more common. That that's because fluorescent light bulbs are much more energy efficient, meaning they don't waste as much electricity, but they can give us even more light. We have an exhibit here at the Michigan Science Center that shows us just how much power an incandescent light bulb uses versus a fluorescent light bulb. Let's take a look. So in this exhibit, we've hooked up two different types of light bulbs. The blue light bulb is an incandescent bulb, one that works off of a filament like the one Thomas Edison invented and Lewis Howard Latimer. Over way on the other side, this white light bulb is a modified fluorescent light bulb. So it looks a little similar, but this one is a fluorescent bulb that is electrifying gases just like our Geisler tubes did. Now, in a moment, we're going to power them on, and we'll get to see the power meter on the bottom of this exhibit start to spin. You probably have a power meter on the outside of your house, or maybe on the outside of your school. And when your power meter starts spinning, you or your parents or your friends or your family, you actually get charged money every time this disc spins around. So let's see the difference between these two light bulbs. So this is our Edison bulb. And take a look at those blue dots. They're moving relatively quickly. Every time that disc spins, you are charged for something that we call a kilowatt hour, or how many kilowatts of electricity you use per hour. Hopefully you use these kinds of bulbs, because look at the difference. Look at the amount of energy it takes to light a fluorescent bulb versus an incandescent bulb. The disc is spinning much more slowly, therefore using much less electricity, but still giving us just as bright, if not brighter, of a light. Now, even better than fluorescent bulbs, we've continued making innovations in the field of light bulbs, right? You might know of something called an LED, or a light emitting diode, which is even more efficient. So if you haven't done so already, take a look around your home or your school, or wherever it is that you spend time the most, and see what kinds of light bulbs that you've been using. If you change out your light bulbs to something like a fluorescent bulb over an Edison bulb, or an LED even over a fluorescent bulb, you will start to save money on your electricity bill. We'll be using less energy, which means that we are not consuming as much of that resource from the world around us. This brings us just about to the end of our episode of Echo Live today. So thank you everyone so much for tuning in. We will be back here next week, Wednesday at 2:30 with another exciting episode. Until then, I hope you all have a great day, and check out the Michigan Science Center's website to learn more about all of the exciting stuff